Bismillahirrahmanirrahim. Hello my friends. Today we will talk about an important lesson for the AC synchronous generators. It's called the generator protection system. A generator is subjected to electrical stresses imposed on the insulation of the machine. Mechanical forces acting on the various parts of the machine and the temperature rise. These are the main factors which make protection necessary for the factors which make protection of the generator or the alternator. Even when properly used, a machine in its perfect running condition doesn't only maintain its specified rated performance for many years, but it does also repeatedly withstand certain excess of the overload. Preventive measures must be taken against overloads and abnormal conditions of the machine so that it can serve safely. Even ensuring an efficient design, construction, operation, and preventive means of protection. The risk of a fault cannot be completely eliminated for or from any machine. The device is used in the generator. It's called the generator protection. Ensure that when a fault arises, it's eliminated as quickly as possible. An electrical generator can be subjected to either an internal fault or external fault or both. The generators are normally connected into the electrical power system. Hence, any fault occurred in the power system should also be cleared from the generator as soon as possible, otherwise it may create a permanent damage in the generator. The number and variety of faults occur in a generator are huge. That is why generator or alternator is protected with a several protective shield. Generator protection is a part of discriminative and a non-discriminative type. Great care is to be taken in according to the system used and the setting adopted to ensure that the sensitive, selective, and discriminative generator protection scheme is achieved. Now, we explain the types of generator protection. It's more important. Please recognize my friends. Types of generator protection. The various forms of protection applied into the generator can be categorized into two manners. 1. Protective relays, as shown in this picture. That we will explain now. Protective relays to detect the faults occurring outside the generators. Like this type of relays. It's used to detect the faults occurring outside the generators. 2. Protective relays to detect faults occurring inside the generators. Now, the generator protection system also consists of 1. The overload that protects this device that protects the generator from the loaded that is over a high in the generators. 2. The short circuits interns between phases. The short circuit interns between the phases. That happens a short circuit between the three phases. There are types of overload. that protecting this generators. 3. The third type of protection system is called the losses of excitation. There are two types of relays that used for the faults in the loss of excitation in the starting of generator. Now, other than protective relays associated directly with the generator and its associated transformer, there are lightning arresters. Lightning arresters that is used in the distribution system. Lightning arrestor, its function is to preventing or protection the transformer in the distribution power plant. Now, the required protection are using a specific ANSI coded rating. The ANSI is abbreviation of the American National Standard Institute. This type of relay function and this code of the ANSI or ANSI. Now, differential protection. It's used 87G. G is the abbreviation of grounded. Number of the code is 87 as shown in this picture. 2. The reverse power protection. Reverse power protection from 32 into 1. 3. Over voltage protection from 1 into 59 and from 2 into 59. That it's used in the generator start point. 3. Overload protection. It's from 1 into 51 and 49G or grounded. Also the neutral earthing resistor is used in the generator for preventing or protection the generator from any losses of excitation or the short circuit in the generator or out of the generator. Overspeed safe, quartz or oil flow devices and temperature measuring devices for shaft bearing or stator winding, transformer winding, and transformer oil non-trip type. For example, they only generate alarm during abnormalities. But the other protective scheme ultimately operate Mr. Tripping relay of the generator. It should be noted that no protective relay can be prevented fault. It only indicates and minimizes the duration of the fault to prevent a high temperature rise in the generator. Otherwise, there may be permanent damage in it. It's desirable to avoid any undue stress in the generator, and for that it's a usual practice to install surge capacitor or surge diverter or but to reduce the effect of lightning and other voltage surges on the machine. The protection scheme usually applied to the generator are discussed here below in brief. Protection against insulation failure. The main protection provided in the stator winding against phase-to-phase or phase-to-earth fault, as shown in these pictures, is a longitudinal for a differential protection of the generator. Second most important protection scheme for stator winding is inter-turn the fault protection. This type of protection was considered unnecessary in previous days because breakdown of insulation between points in the same phase winding contained in the same slot, and between which the potential difference exists, very rapidly changes into an earth fault, and then it's detected by either the stator differential protection or the stator earth fault protection. A generator is designed to produce relatively high voltage in a comparison to its output, and which therefore contains a large number of conductors per slot. With increasing size and voltage of the generator, this form of protection is becoming essential for all large generating units. Stator earth fault protection or neutral earthing resistors or generator start point. This type is called the stator earth fault protection. When the stator neutral is earthed through the resistor, a current transformer is mounted in the neutral to earth connection. Inverse time relay is used across the city or current transformer secondary when the generator is connected directly into the busbar. In case generator feeds power via a delta star transformer. An instantaneous relay is used for the same purpose. In the former case, the earth faults relay is required to be graded with other faults relay in the system. This is the reason why inverse time relay is used in this case, but in the latter case, the earth fault loop is restricted to the stator winding and primary winding of the transformer. Hence, there is no need for grading or discrimination with other earth faults relay in the system. That is why instantaneous relay is preferable into this case. Rotor earth fault protection. A single earth fault doesn't create any major problem in the generator, but if the second earth fault is occurred, however, part of the field winding will become short-circuited and resulting in unbalanced magnetic field in the system, and consequently there may be a major mechanical damage to the bearing of the generator. There are three methods available to detect the types of fault in the rotor. The methods are 1. Potentiometer method, that's used in the schematic as shown in this diagram, is a potentiometer method. 2. AC injection method or alternating current injection method. 3. DC or direct current injection method. So these are the three methods of the fault in the rotor. Unbalanced stator loading protection. Unbalancing in loading produces a negative sequence current in the stator circuit. This negative sequence current produces a reaction field rotating at twice of synchronous speed with respect to the rotor, and hence it induces a double frequency current in the rotor. This current is quite large and causes overheating in the rotor circuit, especially in the alternator. If any imbalancing occurred due to the fault in the stator winding itself, that would be cleared instantaneously by the differential protection provided in the generator. If the imbalancing is occurred due to any external faults or unbalanced loading in the system, it may remain undetected or may persist for a significant period of the time, depending on the protection coordination of the system. These faults can be cleared by installing a negative phase sequence relay with the characteristics to match the withstand curve of the machine. Protection against stator overheating. Overloading can cause overheating in the stator winding of the generator. Not only overloading, failure of cooling system and insulation failure of the stator laminations also cause overheating of the stator winding. The overheating is detected by embedded temperature detectors at various points in the stator winding. The temperature detectors coils are normally resistance elements which form one arm of the Wheatstone bridge circuit. In the case of smaller generator normally below 30 megawatt, the generators are not equipped with the embedded temperature coil but are usually fitted with the thermal relay, and they are arranged to measure the current flowing in the stator winding. This arrangement only detects overheating caused by the overloading and doesn't provide any protection against overheating due to the failure of a cooling system or short-circuited stator laminations. Although overcurrent relays, negative phase sequence relays, and a device for monitoring the constant flow are also used to provide a certain degree of the thermal overload protection. Low vacuum protection. This protection usually is in the form of the regulator, which compares the vacuum against atmospheric pressure. It's normally fitted into the generator set above 30 megawatt. The modern practice is for the regulator to allow the set via the secondary governor until normal vacuum conditions are restored. If the vacuum conditions don't improve below 220-101 inch, the stove valves are closed and the main circuit breaker is tripped. Protections against lubrication oil failure. This protection is not considered essential since the lubrication oil is normally obtained from the same pump as governor oil, and a failure of governor oil will automatically make stove valve to close. Protection against loss of boiler firing. Two methods are available for detecting the loss of boiler firing. In the first method, normally opened, or NO. It's the abbreviation of normally opened. The normally opened contacts are provided with the fan motors which may trip the generator if the more than two motors fail. The second method has used a boiler pressure contacts with a load generator. If the boiler pressures falls below approximately 20% or 90%. Protection agents prime mover failure. If the prime mover fails to supply mechanical energy to the generator will continue to rotate in motoring mode. That means it takes electrical energy from the system instead of supplying it to the system. In a steam turbine, the steam acts as a coolant, maintaining the turbine blades at constant temperature. Failure of the supply will therefore result in overheating due to the friction, with subsequent distortion of the turbine blades. The failure of the steam supply can cause severe mechanical damage in addition of imposing heavy motoring load on the generator. Reverse power relay is used for the purpose. Reverse power protection relays, as shown in these pictures, 32P or 32 protection. So for this purpose, as soon as the generator starts rotating in monitoring mode, the reverse power relay will trip the generator set. Overspeed protection. Overspeed protection. While it's the general practice to provide mechanical overspeed device on both steam and hydro turbines, which operate directly on the steam throttle valve or main step valve, it's not usual to back up this device by an overspeed relay on steam driving sets. It's, however, considered good practice on hydroelectric units, as the response of the governor is comparatively slow and the set is more prone to overspeed. The relay, when fitted, is usually supplied from the permanent magnetic generator used for the control of governor. Protection agents rotor distortion. The cooling rates flowing shutdown at the top and bottom of the turbine casing are different, and this uneven temperature distribution tends to cause dislocation of the rotor or the destruction of the rotor. To minimize the disruption is a common practice to turn the rotor at low speed during the cooling down period. In the view of the force involved with the large modern rotor, it's now standard practice to fit shaft eccentricity detectors. Protection agents difference in expansion between rotating and stationary parts. During the running up period, the rate of heating the rotor differs from that of the casing due to the difference between in mass. As a result, the rotor expands at a different rate to the casing, and it's necessary to overcome this and equal expansion. Though, to this end, propositions is made on the larger machine for independent independent supplies of the steam to be set to certain points on the casing. It's desirable, therefore, to provide a means of measuring an actual expansion to assist the operator to feed the steam to correct point and also to provide indication of any dangerous expansion. The shaft axial expansion detector is basically similar to the equipment described for roller distillation equipment, except that the detector's magnetics are fixed into the turbine casing. Protection against vibration. Vibration detectors are usually mounted on the bearing pedestals. The detectors consist of a coil mounted on a spring between U-shaped permanent magnetics. The voltage output from the coil, which is proportional to the degree of vibration, is passed from the coil into integrating circuits and then into interval indicating instrument. Backup protection of generator. Backup protection should also or always be given in highly rated machine like synchronous generator or the alternator. If faults occurred had not been cleared by the appropriate protection scheme, then cleared or backup protection relays should be operated to clear the fault. Overcurrent relays are generally used for this purpose. Because the synchronous reactance of modern machine is often greater than 100%, the sustained fault current feed from the machine into an external fault is invariably below the normal full load current. The normal ID in relays would not be proved satisfactory because their current setting must be close to the full load and their time setting short is or if operation is to be obtained, resulting in proper lack of discrimination with other overcurrent relays in the system. Further, the overcurrent or the overcurrent relay would mostly probably operate for a loss of field on the machine. Disconnecting it permanently or prematurely to overcome this problem is it has become customary to apply an overcurrent relay in combination or with undervoltage relay, the latter relay controlling the fault setting of the former as shown in the figure below. Also, are all this about the generator protection system of my lesson tonight. Thank you, my friend, for your listening.